Okay, thanks everyone to our talk about OpenTelemetry and AEM as a cloud service. I'll first introduce ourselves. I'm Roy. I work as a freelance AEM architect at the AmeXio Group, customers for AmeXio. I'm also working as an open source contributor for Orbinson, which is a GitHub organization related to tooling in AEM to improve the AEM developer experience. And lastly, I'm also an Apache Sling committer. Besides myself, I have Barry with me, who's a software engineer at the AmeXio Group and also an Orbinson open source contributor. So, what is this talk about? This talk is a story about observability. I'm going to start up with some screens here that we all hope we never see. It's a bad day when you get to these screens in AEM. The right one, it's a screen that you get when the author system is unavailable. The left one is even worse. That's when the publish system is unreachable, and you really don't hope to have that when you open up your browser. So what do? When you have these screens? You start troubleshooting. You'll have a look. Is it a performance issue? Is there something going wrong? Can I check in the logs what is going on? Do I have to debug some code? Maybe it's your own code, it's some vendor code. To give you some examples, like we had an author system where we had the service outage and the logs were not really showing anything. Then further digging into it, we saw that there were a lot of Sling jobs being created. But we really didn't have any clue that that was happening because there weren't any metrics about that. We just found out by going to CRX, having a look at the Sling jobs or using the developer console browser to find out. In the end, it seemed to be customer code, but it took us a while to find out. For the publish, we had the same issue. We went live with a client on production. Everything was going well up until production, but when we launched, we got that service outage. And it seemed that the requests were going really, really slow. So again, we looked in the logs. Yeah, you can see that a request is going slow, but why is it going slow? Again, the logs didn't really show anything. It seemed that pods were getting restarted, they were being killed, there was a lot of memory consumption, and together with Adobe, we actually found a bug in the Apache Sling code and had it fixed. But this made us think, how can we improve on this? Because we don't want to go through all these loopholes to debug, get to the logs, checking, debugging code. As you know, remote debugging isn't even available in the cloud service, so it really makes it a pain in the ass. So that's when we got to the concept of observability. Observability is a concept where you're looking at your system and you can see what's happening by looking at the telemetry data. Telemetry data is all around traces, metrics, and logs, and Barry will explain on that in the upcoming slides. When you have telemetry data in your system and you're exposing it, then you say that your system is instrumented. And this will help you to know what's going on in your system without having to look at the inner code. When is a system properly instrumented? Well, when you have these kinds of service outages and you don't have to go and add extra telemetry data, do deployments, and see what's going on. You hope that with all the telemetry data that you have, that you can already find the problem. Okay, now that we have the concepts of observability, let's have a look at AEM as a cloud service. So this is the basic architecture of AEM as a cloud service. You have an author, you have a publish, you have a CDN, a dispatcher, and all of them already natively generate telemetry data. You have logs, which are sent to Cloud Manager, and you have some metrics sent to New Relic. How does that look like? This is New Relic. So New Relic is an application performance monitoring tool that will show you how many pods are running. What is the CPU? What is the RAM doing? Maybe also a little bit about the requests, how slow they're going or how fast they're going. So it already gives you a fair image of what's going on. For the logs, sadly enough, they're not in there. So you go to Cloud Manager and you can manually download them. But yeah, that's not that awesome. You can also use the Adobe I/O CLI to tail the logs. Again, yeah, that's delayed and chunked, so doesn't really help you that either, because if you're actually opening a URL and hoping to see the logs immediately of what is going wrong, yeah, no, you'll have to remember the timestamp and then see what's going on after 10 seconds when the logs appear. So these are the two tools that are available natively. But this is AEM as a cloud service. And I work for customers. And customers, they don't only have AEM as a cloud service. This is more like a real platform. You have a plethora of other services around it, a search service, some microservice connecting to a CRM system, a cloud tool, another one like Elastic in here, and they also generate telemetry data. And they send it, for example, here to Prometheus, which is their central APM tooling. Okay, what happens now? A customer has an issue. Their search page is not giving any results. What do? Where will you look? Will you go to New Relic to have a look if there's an issue in there? Will you download the logs from Cloud Manager? Maybe you need access to that Prometheus tool, but you don't have it because you're an AEM developer and you only have access to that New Relic. So going back to the platform, we clearly see that there's something missing. AEM is a closed down system and there is no telemetry flow going to Prometheus or other tooling that the customer would have. So this showcases Adobe's New Relic shortcomings. It's not enough. Adobe is the driver in a walled garden where they have the telemetry data, they decide what is tracked in there, and you can only have a read-only view, you don't have alerting. So if you want to know up front that something is going wrong, you're not even able to. So if you also have those customer integrations like the search or the microservice, you cannot push that to New Relic. So this is really a lacking feature in my opinion. That's why we got together and had a look at what we can do about this. And so OpenTelemetry came into play. And Barry will go further on what that is.
Right. Now that we realize that our system needs to be observable, we came to OpenTelemetry. But what is OpenTelemetry actually? OpenTelemetry is trying to have a vendor-agnostic approach in adding instrumentation to your services. Also, what is important to know about OpenTelemetry is it doesn't want to own your data. So the storage is left to the vendors or yourself, and also the visualization is left to the vendors because there are already many tools like Dynatrace, New Relic, Datadog that do a decent job there. What OpenTelemetry also tries to do is to standardize the concepts. You have semantic conventions to see, for example, how can I add some attributes, what is an HTTP request, what is a status code, how are the fields named, and also OpenTelemetry defines some concepts about how you name your telemetry data. And then we come to the 3 dimensions of instrumentation provided by OpenTelemetry, and those are the first one, traces. A trace is actually, you can see it as a request coming into your multi-service architecture. So for example, a user does a request, it goes into AEM, AEM goes into a product backend, that product backend also does a query. That you can see that in OpenTelemetry as a trace. Of course, a trace is very granular. If you want to be more specific about the transactions within a trace, we call it a span. So actually, trace consists of different spans. Another concept, the second dimension, is metrics. Metrics are exposed. It's like Sling metrics. It are at a specific point of time a measurement of data. It can be the number of Sling jobs. It can be your CPU, whatever. And another thing that OpenTelemetry tries to solve is the logging problem. They're not want to create a logging interface. The only thing that they do is they bridge the logs. And the power of OpenTelemetry is by connecting these 3 dimensions. So if you have a trace, a metric, or a log, it will always be tied together. We will demo that later. Important to highlight is that traces are distributed. So it's not tied to one specific service. Traces can span over several services. So now that we know what the basic concepts of OpenTelemetry are, how can we do this? The thing I would recommend is zero-code instrumentation. How can you do it? For example, in Java, you have a Java agent of OpenTelemetry. You put it in you inject a jar on startup, and then before the classes are loaded, the OpenTelemetry agent will wrap some classes, put some traces, put some spans there, and automatically your application is getting instrumented. Sadly enough, in AEM as a cloud service, that's not possible yet. AEM as a cloud service at the moment supports injecting the Dynatrace Java agent, but for OpenTelemetry, there's no support yet. Of course, it was no problem because you don't only have zero code instrumentation, you also have code-based instrumentation. And here you can provide the SDK yourself. And if you have the SDK, you can use it inside your own applications. So what did we need to do? To enable instrumentation in AEM as a cloud service, at first we wanted to see, can we load in the jars from OpenTelemetry into an OSGi container? It was not possible because it was not having the manifest headers. So what we did is we created a separate project to wrap all the modules and make them available to your AEM instance. The second step we did was we created a service where you can load in the SDK so that you can use it in your own filters, components, whatever. Afterwards, we had the SDK injected. Cool, now we provide some Sling filters. We have 2 out-of-the-box Sling filters that we provide also in our implementation. The first one is a request filter. So every request that now flows through AEM is instrumented. It has the metadata about the request. If it comes from another service that also have OpenTelemetry data where the trace is originating, it's added to the parent trace. So it really processes everything. And what you also can enable in the AEM implementation is component tracing. So every AEM component will be a dedicated span. And finally, what we also did is we provide a logging bridge. So every logging statement that you create that usually goes to the Azure Blob Store that you can do a tail on with AIO or in the Cloud Manager interface, also those will be exported as telemetry data with the OTLP protocol, the OpenTelemetry protocol. This is an example. After we enabled the bundle in our implementation, you can see here a screenshot of a trace. The trace is from a search page. And we had an issue with our pages. They were like taking 2 seconds to render. And here you can see in the flame graph, every component has a span. And you immediately see that the main navigation is taking like 90% of the rendering. Also, yeah, here there are no logs emitted. As we said in the introduction, there were no logs. So you can see there are no logs here linked, but we immediately can pinpoint the problem. So what are the disadvantages of this approach? Of course, no auto-instrumentation. If you use an HTTP client inside your code, or you have some other third-party libraries, they're not auto-instrumented as you would like to have with the Java agent. And also, because the telemetry, OpenTelemetry is a OSGi bundle, it doesn't come up immediately with the Java agent. It's like immediately you get all the telemetry data, all the logs. Here you have to wait until the bundle is up, of course. And also, with this approach, it's really hard to instrument out-of-the-box code because, yeah, you have to write custom code to have the metadata and the traces and the spans there. And this will all be solved, yeah, if we would have had the Java agent. Some possible enhancements. We can expose the Sling metrics, for example, as OpenTelemetry metrics. That would help because there are a lot of metrics exposed already, but they're not available as OTel metrics. Another thing that we see, what is also currently missing in the implementation that we open sourced, is to have the annotations. We will also demo that later, that you can easily instrument your code without writing too much code. So how is this visualized? We now know how we get the data out of AEM. There are already a lot of vendors, or quite some vendors that are big who support OTel natively. So you can just send all your telemetry data, logs, whatever to these, and they will just work. They will visualize it decently. However, not every vendor is supporting it, but that's no problem. That's where the OpenTelemetry collector comes in. It's a kind of a proxy where you send your data to. You can have multiple inputs, and then you have also some functionality to do some batching, also filtering, maybe enhancing your data, adding some extra attributes, and then you can also export them. The main advantage of the collector is it's vendor agnostic, but the vendors, they implement the exporters. And as you can see in this picture, for example, if you have a customer where you have some services who talk OTLP natively, the OpenTelemetry protocol, and you have some Prometheus exporters, you can send them to the OTel collector. There you can do some batch processing, you can add some attributes, whatever, and then you have the exporters. So you can actually send all your instrumentation, your telemetry data, to Datadog, for example, but also if you have Elastic APM for other departments or you want to enclose your data there, you can do it, you can expose them all, and you don't need to change your implementation. You don't have to inject for every service a specific vendor. library. You just use the OTel protocol, it gets processed, and then you can visualize it. When using exporters, the vendor support is really broad. These are some vendors that support the OTel using the collector. So they have an exporter. The main advantage is here. For example, for Datadog, that's what we're going to use in the demo. They maintain the exporter themselves. They also have a good incentive to maintain it because, of course, the better support they have in the exporter, the more customers who will buy your product. All right, demo time.
Now we go to the demo. What do we have as a demo? So we have AEM. We're going to use the AEM SDK. And there we have the code-based instrumentation, because there is no Java agent, where we have the request and component spans. And we use a microservice that does have the Java agent. We're using the Spring Boot here, where we have zero code and framework support. So there we can use, for example, annotations for adding spans in a more easy way. The references of the demo are here, and I'm going to start by showing the OpenTelemetry OSGi wrappers. So there are 3 projects. If the question hasn't been asked yet, yes, they're all open source. We have an OpenTelemetry OSGi wrapper project. This is where we actually wrap all the OpenTelemetry jars to add the OSGi headers. Why? For people who don't know this, OSGi works based on manifest headers. And those manifest headers, they're in your jar, and you need them to actually register a jar as a bundle. Natively, OpenTelemetry doesn't support this yet. They don't have the manifest headers, and we've been actively trying to get it into the OpenTelemetry project itself, but they first wanted real integration tests showcasing that if we add all the bundles and we have an OSGi framework, that it all works. So that's why we decided to start our own project. We have all the bundles in here. We use the BND Maven plugin to add the headers. And then we have an integration test based on Sling feature model, where we have all the bundles for OpenTelemetry, OSGi, all the exporters to start up the application. And then we have a test class that uses the feature model to check, are my bundles active? And can I actually also have an OpenTelemetry in my OSGi application? In here, we're using the in-memory exporter, so it's just exporting it into a memory map, not going to a real collector. This is just an integration test, but this showcases that it works in OSGi. So the next step would be to contribute this back to the OpenTelemetry project. There are definitely some hiccups during the way. What happened is that OpenTelemetry uses the service loader principle, which is a vanilla Java way of working to expose services in different jars. And to make that work, we had to use Apache Aries SpyFly. That actually wraps those jars to add extra manifest headers, where you say this specific class is a sort of OSGi service. It's not a real OSGi service, but it will be registered as an OSGi service so that you can use it in your OSGi environment. At this moment, these headers are sadly enough added manually. As you can see here, we have to do this manually. But I've been working together with BND to get it into the 7.1 release. Once this is released, this will actually be auto-created by using the BND Maven plugin. They will scan the service loaders in your jar and generate the correct headers. So if this is released, then I'm more confident that OpenTelemetry will accept it, because I'm pretty confident that they don't know this. They already said we know nothing of OSGi, so we're reluctant to just merge in stuff. So this would be my first step, getting BND 7.1 released. Besides this, there's also the exporter. They have 2 kind of exporters based on Netty and OKHTTP. OKHTTP, we had the luck that it's already OSGi compatible. They have a service mix bundle, so you can use it in OSGi, so we decided to go for that exporter. If we go for the Netty one, that one uses gRPC, and then I had to go into the hell of wrapping all of those as well. So at this moment, it's only OKHTTP, but it shouldn't matter. It's only below the scenes to send the data to the collector. This was it for the OpenTelemetry. Once we had all these bundles, we of course had our own AEM as a cloud service, OpenTelemetry instrumentation. And in here we have a few classes that we provide, for example, we have the OpenTelemetry Factory, which is an OSGi service to get the OpenTelemetry inside your OSGi components or Sling models. We have a config to enable specific parts, to decide what the name is of the OpenTelemetry instrumentation. If you use the logging appender, where you actually also send the logs to your APM tooling, then you can specify which packages should be sent. We have the OpenTelemetry OK HTTP exporter package that contains everything required to start up OpenTelemetry in AEM as a cloud service, and then the minimal package that only contains our API and our core bundle. Within the core bundle, we have some filters that will do the request filtering. So if you have a request, it will automatically say, this is my URL, this is the query parameter, this is the request method. So this will all automatically be instrumented when you do a request to your AEM instance, that it will send this to the APM. If you want it also on component, then it will use the component servlet name to add those custom spans that you saw in the flame graph that Barry showed in the presentation. That's it for the actual things that we use. We created, and then we also created a reference project that Barry will show, where we actually use the OSGi bundles.
All right. Also, this repository is public. What is in there is an AEM project, like started from the archetype, where we include the bundle that Roy just showed. There's also a Spring Boot service to get you acquainted with calling multiple services. There's also an example of an OTel collector. It's just using a Docker container that is provided by OpenTelemetry. The configuration is also there. It's just a config file for the collector, for example, for Datadog and file exporter. Here you can see there are two exporters. One will send the traces to a file and the other one's to Datadog. How does this look like in real? For example, what we created is we created a product page, and that product page will just simply do a call to the Spring Boot service. So if I just refresh this page, another use case can be that the product service is coming back to AEM. It's not a very production-like pattern, but it's to indicate the distributed traces. And if we then go into our APM tool, you can see here, for example, the first page that I requested was this one. You can see this is the main trace. The product page is doing a get. This one is using an instrumented HTTP client. Also, this is something the SDK provides. I will give an example later. And here you see the second service, which is a Spring Boot service, and you can also see the timings. Of course, in the other frame graph, you saw that the component tracing from AEM was also there. There's an OSGi config for that. If you enable it, you can say, okay, I want to trace my components. You just enable it. Then again, you can go to the product pages. There are different variants. You can find them all in the README. You can also generate exceptions. For example, this one will generate exceptions in the backend. Also nice to notice is, let me refresh this one. If you take a look at the logs, okay, not live till last 15 minutes. You can see here that actually all logs are aggregated here. And if I now start from the logs, for example, to see what is happening in the system, you see that this gave an error. Here you can see that also all the OpenTelemetry attributes are added. You have a timestamp, which environment, where it's running, which OpenTelemetry you're using, also some other things. And if you go to the trace, you can see here, I will open it in larger. Here you can see, okay, the error originated on the HTTP client that did a get to the product service. And here you see that there was an error. If you here go to the error, you can immediately see what the exception was. And also the logs are exposed here. And you can also see that logs from multiple services are being linked to the trace. If there would be metrics, but in this demo there are no metrics, you would also be able to see them here. For example, if you see that something is rendering slow and you see a high CPU, you will immediately see the linked data and you can connect all dots. think that was most of the things.
Here you have the capability to add your alerting. So if something goes wrong, you actually proactively will know. That's one of the main advantages. You see the services all connected. So also there you can get a holistic view over your entire platform and not just AEM as a walled garden. So this is what we wanted to achieve.
Yeah. And also if you, for example, here see in the dashboard, this is the general traces. So all requests originated from the AEM author. You can also see the metadata that was automatically added. I didn't have to write any custom code. You can also filter on all service entries. So for every specific service, you can also see where the trace started for that specific service. And here you can immediately see, for example, the error that I found in the logs. Now I find it starting from traces. How this actually works, maybe that's also nice to mention. For example, Spring Boot already has native OpenTelemetry support. And the things that you see, the spans and the traces that are there, mostly are generated by the framework if you implement the controller. But what you also can do, and that's the annotations that I mentioned, for example, in this service, you can see by adding this with span annotation and this span attribute annotation, it will automatically meter or instrument that method. And if we go back to the trace itself, if I take one that did not fail, and I zoom in here, you can actually see that the get product method is being spanned. So there's a span around that method by just adding that simple annotation. And if you go to the span itself, there should be somewhere here the ID that I fetched to give the product error is actually this ID. So you can easily add extra telemetry data by just using a simple annotation. For the bundle that we provide, it's not yet possible.
There you have to write boilerplate code, as is shown in the request filter, where you actually have to start a span, add the request attributes using a builder method, and then it also is possible. It's just more boilerplate code.
And to show you an example of the OpenTelemetry factory that's being used, for example, here we inject the OpenTelemetry factory service, and if you use the HTTP client that is made available with the Open SDK, the OpenTelemetry SDK, and you use that as an HTTP client, the OpenTelemetry gets injected, and then every request you use with that client is also automatically instrumented. So that's also quite nice that you don't have to, for every method that you write to do an HTTP request or whatever, that you have all the instrumentation there and everything has its own spans and metadata.
Okay. I think we showcase all we wanted to show.
Yeah. And everything, you can find it in the references, but it's open source. It's released 1 hour ago. So we find some last-minute bugs, but we tested it on our RDE and it worked. So we also have the non-open source because it started closed source. We have it running in production. Important to say also for OpenTelemetry, one of the main goals of OpenTelemetry is that it's always on. They don't want you to enable debugging or like say we have issues now we start our telemetry. The goal of OpenTelemetry is to have observability everywhere. So every service, all those spans need to be present everywhere. So you can just look at your system and identify new problems as we mentioned before. And these are the references. Everything is on GitHub.
Yep.
Okay.
So, brought some question, is there any performance impact on the application?
No, we included it in production sites, and we don't see any impact on the request. It's not slowing down the application at all, even though we have the component tracing on. Like it generates a lot of spans. Actually, the only limiting factor for us was that we needed to pay a lot of money for having all that data.
So what you can do there for that case is you can also say that you sample the data. So you're not, you can say like 10% of the requests are actually sampled so that you don't push all the data, because if you have 1 million visitors, 100,000 will probably also introduce all those errors. For the performance, what OpenTelemetry does, it actually has a batch span processor that has a queue. So all the data is first added to a queue, and then the request goes on. It's not immediately exported. That's actually a separate background task so that there is no overhead for the OpenTelemetry data being sent.
All right. Do you instrument Apache Dispatcher and the CDN to preserve complete traces?
In on-premise situations, yes, but in the cloud, we are not able to do that.
Do you send all spans traces, or do you use samplers? You just highlighted
Yes.
that. Yes,
The
we
cost
talked about
is
the
enormous
sampling.
else.
Yeah. Then that's not a, yeah, it's part of the questions. First thought, this is amazing work. Yeah.
Thank you.
What sort of delay are you typically seeing for log data for AEM as a cloud service with this framework?
For log data?
Yeah. So when the log statements are emitted, they're like in 5 to 10 seconds available in the visualization tool. Also the traces, if you do the request, it takes a few seconds to show up there. And they're, yeah, go ahead.
Also important which APM tool you're using, because in the demo, we included an open source APM tool called Signals. You can start it up. There is a Docker Compose file in there. And first we were going to showcase it with that. And sometimes we had to refresh for a minute just to get the data in there. So that's why we decided to use Datadog. Because you can really see it depends on how fast they ingest it. OpenTelemetry itself is really fast in sending it out. It depends on how you configure the batch processor, on how much it should batch in one go, what is the timeout. So it's really configurable. What I maybe didn't mention is all the configuration that is in there is done through environment variables. So you can actually, in Cloud Manager, configure it using your environment configuration. You can say that you trace, that you sample on production 10%, on stage you don't sample. All those things are configurable through environment variables.
Well, how do you link spans with exceptional log entries? Do you attach exception to the current span in case of an error or a failure?
Yeah, everything is connected together. So that's one of the main advantages, not only having telemetry data, but they are automatically added. So loggings are attached to the spans are on the traces, exceptions are there. If you have support for your source code, you can even have the line where the source to your source code repository where you can find the original code.
Barry, Roy, thanks for your presentation.
Thank you.